Hi, I'm Rob, and I'd like to welcome you to the next video in the AI on AWS playlist on the Cumulus Cycles channel. In this video, we'll look at a multilingual chat application which uses Amazon Transcribe and Comprehend to translate chat messages between English, Spanish, and French, as well as provide color-coded sentiment analysis of the message text. Now, before we get started, I want to mention that this video is a continuation of the prior AWS purpose-built AI services video, in which we looked at several AWS AI services, both in the console as well as in a Jupyter Notebook, to make API calls. If you're not familiar with these services or how to make simple API calls, you may want to check that video out first before continuing here. Okay, with that out of the way, let's get started. Now, as with the last video, I'll provide a link to the GitHub repo with the code in the description below. In this video, we'll be focusing on the _purpose-built AI services demo apps folder, and specifically the app in the multilingual chat folder. As previously mentioned, this app uses AWS Translate and Comprehend in a real-time chat application via API calls to the services. The implementation uses WebSockets to communicate between the Fast API backend, which calls the AWS services, and a React frontend, which displays the chat interface. Let's jump into Cursor to take a closer look. First, I'll expand the purpose-built demo apps folder, then the multilingual chat app folder, then preview the README, and we see the setup steps for configuring the app. Because this is a full stack app, we have both a backend folder and a front-end folder, as well as a root.env file in which we'll place our AWS config credentials. You could copy the .env.example file and save as a .env file, then update accordingly. I'll do this off camera quickly so we can launch the app and take a look before diving into the code. Now I'll open the backend folder in the terminal. And because I've already created my UV environment, I'll go ahead and activate it. And although I've already installed dependencies, I'll do them again. I've already set up my .env file. And now I'll launch the backend app. So as we see here, the backend app's running on localhost 8000. So if we jump into a browser and hit the docs endpoint, we see our health check. And that looks healthy. Now for the front end, I'll open that in another terminal. And I've already run npm install, but you could go ahead and do that. Then I'll launch the app. And this is running on localhost 3000, so let's jump back in the browser and load the page. Now, because the back end is running, we see that we're connected on all three panes, which are used to simulate a chat session between three people, the first typing in English, the second in Spanish, and the third in French. Down at the bottom, you see a key that indicates that the message being typed for the current person will be shown in blue, and color codings of green for positive sentiment, black for neutral, and red for negative. So let's go ahead and start chatting. First, I'll send a message in English. And we see here in the pane for the person typing in English, the message is in blue. The second pane shows the message in Spanish, and the third in French, and it's color-coded in green for a positive sentiment. Now let's send a message in Spanish, which again we see the message in blue for the person chatting in Spanish, and then the translation in English and French, again with a positive sentiment. Now we'll send a message in French, which is also positive, but let's send another message in French, which shows as having a negative sentiment because the person caught a bad cold and couldn't celebrate the New Year. We'll send a reply in English and Spanish and respond in French. Now let's ask a question with a neutral sentiment in Spanish. And we see the text in black. We'll reply, then send our final chat message. Now, as I previously mentioned, the tech stack used to build this app uses a React front end with a WebSocket client and a fast API backend which accepts the WebSocket request. The backend also uses the Boto 3 SDK to send API requests to the AWS services, then sends the response back to the front end over the WebSocket. Of course, you can use any front end you want, so I'm not going to dive deep into that code since this isn't a video on front end app development. But we will take a look at the backend code which sends requests to and handles responses from the AWS services. Looking at the code in the main.py file, we see our imports, but let's take a look at the config file. Here we see we're loading .env and the path to the .env file, and getting the AWS configuration values from the .env file, as well as backend host and port, setting configuration for cores, as well as adding a property for languages, and configuring logging. Next, we'll instantiate an instance of a fast API, then add the core's middleware, and initialize, translate, and comprehend instances, which if we scroll back up, we see we're importing from the services folder. Here we have a connection manager class for the WebSocket, in which we instantiate an instance and assign it to the variable manager, which will handle communication between the front end and the back end. Here we're registering our health check and the WebSocket endpoint. When we receive a message from the front end, we'll identify the sender and the text and set the target languages to translate into. Then we'll call translate to multiple on the translate service, passing it the text, the target languages, and the sender language. So let's jump into the translate service source code. First, we see the import for the Boto 3 SDK with additional imports. And from config, we're importing the AWS region. When an instance of the translate service is instantiated, we'll set the region name, create a Boto 3 translate client, and a thread pool executor for concurrent translations. The translate to multiple function is what's called from main, and it will create a list of tasks calling translate text for each target language in target languages. Translate text processes in a loop, awaiting response from calling the translate text sync function, which calls translate text on the client, passing the text, the source code language, and the target language, then returns the response to the loop, which is then returned to the translate to multiple function, stored as results, converted into a dictionary, then ultimately returned and stored in the translation task variable in main. Next, we'll call detect sentiment in the comprehend service. So let's launch that code, where again we see the import for Boto 3 and the AWS region, which is set on the instance of the comprehend service. A comprehend Boto 3 client is instantiated, and we're using thread pool executor. Since detect sentiment was called from main, we follow a similar pattern by waiting a call to detect sentiment sync, which calls detect sentiment on the client, passing the text and the language code, which will return the results, which are returned back to main and stored in sentiment task. And main waits for both calls to complete. When the responses come back, we'll build a message, just sending the original sender's message back, as well as the translated messages with sentiment. Then we'll broadcast the message back to the front end. So that concludes this video walkthrough of the multilingual chat client with Amazon Transcribe and Comprehend integration. In the next video, we'll look at an insurance claim submission app, again with a React front end and fast API backend, which uses Amazon Comprehend, Textract, Recognition, Translate, and Poly. I hope to see you there.